So we've got light ejecting photoelectrons, right? So here's this metal, and photon comes down. It's a strange photon, right? And there's this electron on the surface of the metal. It's going, wee, I'm as loosely bound as I could possibly be, right? And then afterwards, the photon is absorbed, and the electron is given some amount of energy, right? The basic idea behind this is that the photon energy, right, turns into, in the best case scenario, right, turns into work to remove, right, plus whatever's left over can be possibly turned into the kinetic energy of the electron, right? Now, since we measure the kinetic energy by seeing how many volts the electron can go through, this will be in electron volts. Work functions are in electron volts, so we have to turn our photon energy into electron volts. So the key here is do everything in electron volts. Okay, so step one is to figure out the energy of a 400 nanometer light, right? So you get, I think lambda is hc over E, so therefore E is hc over lambda. Right, so 6.626. By the way, in the front of your data packet, there's an intriguing thing. They give you HC in joules, joule meters, right? And then they also give you HC in electron volt meters, which I think is kind of interesting, right? You could just presumably put that value in here, divide by this, and get energy automatically in electron volts. I'm not going to do that, but I'm going to do it traditionally. 400 times 10 to the minus 9th, right? And then, of course, we know we got to divide this whole thing by 1.602, because this will be joules, right? This is joules per electron volt, right? This is meters, this is joule seconds. Meters per second. So this whole thing here, this will be in joules when it's all done, and then this will get it, right? 6.626. This will turn it into electron volts. E minus 34 times 3 E8 divided by 400 E minus 9. And I'm getting 4.9695. That's joules, right? Divided by 1.602. Divided by. If you had like a TI-85 or TI-86, these constants, Planck's constant, speed of light, the elementary charge, right? Those are actually all built in, which is kind of cool. So I'm getting that is 3.102 electron volts. So that's my photon energy is 3.102. Right, and then let's see, the photoelectrons have a stopping potential of 1.17. So that is their kinetic energy, right? They can go through 1.17 volts of reverse potential before we stop them, right? So that is this 1.17. That means that the electrons have 1.17 electron volts of energy, right? And then the work is this. Now there is a weird formula or something that involves subtraction that is in the data packet. But I just don't tend to use it. Anyway, so basically to find the work function here, we just have to subtract. So I'm going to subtract 1.17, and I get 1.932 electron volts. So that is, the work function is the amount of energy, the minimum amount of energy that you can give the electron that it will escape, right? It's how hard it is to remove the electron from the surface. Alrighty.